Hello everyone. Now in this video we will see how to draw the orthographic projections of a square pyramid when its axis is inclined to HP at an angle. In the previous tutorials we discussed about the axis of the cone inclined to HP, axis of the cone inclined to VP, cylinder, everything. And now we are going to see about the square pyramid. So before drawing, let us recall what is a square pyramid. You can see that the square pyramid, which has one base, it is in the square shape, and all the sides with the triangular faces connected to a point called apex point. Square pyramid which is having four sides, so four triangular faces connected to a apex point. In the question we saw that it is resting on edge on HP, one of edge resting on edge with one on HP with one edge, and the axis of the pyramid is inclined to HP. So before drawing the axis inclined to HP, initially the pyramid axis will be perpendicular to HP. You can see that when the axis is inclined to HP at an angle, so initial stage will be axis perpendicular to HP. So first we will draw when the base is on HP and the axis is perpendicular to HP. So you can see that when the axis is perpendicular to HP, the top view appears as a true shape of the base, that is square, and all the slant edges CO, BO, AO, DO, everything connected to the apex point. So this is the top view, whereas in the front view you can see that clear triangle. Yes, now we will see the same here. Initial case, stage 1 drawing. So now polygon, number of sides 4, which is the true shape of the base. I am drawing it in the top view. Yeah, side is 40 mm. Okay, so we made this side, and now let us give so here we starts with A. Okay, let us give the A only. A, B, C, D. Okay, so we finish this one, the base A, B, C, D. As I said, when you see the pyramid from the top, all the slant edges will meet to the apex point, so we should draw it. So take the line and connect all the lines towards the apex. Yes, and now we are going to draw the front view and draw the projectors till the reference line. And now in the front view we can see that a triangular shape, that is AOD, whereas BOC is invisible to the observer. When the observer views from this direction, the BOC triangle is invisible. So that's why in the front view you can see that A dash is visible, D dash is visible, whereas B and C is invisible. That's why I kept it in brackets. And the apex point is clearly visible, O dash, and this is the axis of the pyramid. So now I am drawing the axis of the pyramid. Height is 70 mm. Okay, side 40 and height 70 mm. Okay, so now I am connecting to the apex point. Okay, so I drawn the axis, slant edges, and now I am drawing the base of the square pyramid. We'll give the text. This is the apex point O dash, and in the top view the apex point is O. Okay, and coming to the base, the observer views from this direction, so A is visible, B is invisible, so that's why A dash of B dash. And coming to here, D is visible, C is invisible, D dash of C dash. Okay, clear. Now let us give some line weight. Line weight display on. Okay, good. So we finished the initial case when the square pyramid is resting on HP, just resting on HP. And now the additional condition is that it is resting on HP with one of its edges. So here all the edges are on the HP, you can see that all the edges on HP, but the second condition is it is resting on only one edge. Out of these four edges, I am going to tilt only one edge, that is I am going to consider resting edge is CD. You can see that the resting edge is CD and all the remaining edges are in the space. Also, after resting on one edge, the axis is inclined to HP at an angle of 30 degrees. So this will be the final position, resting on edge CD and axis is inclined. So when you see from the front side this inclined position, the front view appears as the same triangle just with inclination. There will be no change in the dimensions, just this square pyramid will tilt to this position. So therefore there is no change in the front view dimensions except the inclination. So that's why instead of drawing, I just Control C, Control V. Okay. So first we'll load the line types for the axis. Load, center to for axis, load, dash it to for hidden lines. Okay, so this is the axis, right? So that's why I will take axis, center to. Okay, perfect. So as I said, there will be no change in the dimensions of this one except inclination. Now you can see that dimension, angular, the axis is exactly perpendicular to HP at an angle of 90 degrees now. But in the question they asked us that axis is inclined to HP at 30 degrees. So now I need to tilt. So what I am going to do is that, okay, let me delete this one. Later we'll check it out. Okay, rotate. So axis, that's why I am taking always specify base point with the axis, not with the base. Oh, always take the axis here, base point. Okay, now it is 90 degrees, but in the question they asked us 30 degrees. So that's why, as already we discussed in the previous tutorials how to make rotation. So to do that one, I am going for minus 60 to get the 30 degrees. 90 minus 30 equals to 60. So minus 60. Yes. Move exactly from this point. Okay, nice. So now you can see the same, resting on edge CD. So that's why on the reference line you can see D dash of C dash, A dash of B dash. The same you can see here, D dash of C dash and A dash of B dash. Now you can check it out, the axis inclination, it will be 30 degrees. See, perfectly 30 degrees. Axis is inclined to HP, 30 degrees. Okay, now to draw the final top view, see, when you see this inclined pyramid from the top, so to draw this one we will construct step by step. First we will draw the visible and invisible edges from the top. When you see from the top, the resting edge CD is always hidden, so not at all visible, whereas BA is visible, AD is visible, BC is also visible. When you see from the top, BA, AD, BC will be visible, whereas CD is invisible from the top. So first let us mark all the points. Okay, this is from the apex. I drawn the vertical projectors and now horizontal projectors. Okay, now we'll mark these points. So we know that the common points, this one belongs to AD and this one belongs to AB. So this one will be the A1 and this one will belongs to the B1 and this is C1 and this is D1 and this one will be the O, right? So O1. Okay, this unnecessary part will trim it. Okay, yes. So now we'll draw the lines. Take the line A2, B, B2, C, C2, D, D2, E. Okay, so we draw all the 4 edges. Okay, just now as I said, to select this one. Okay, so when you see from the top, as I said, the edge CD is invisible. So mark this one and then dash it too. Now you can see invisible line. So it's overlapping with the projector. Now you can see. Whereas BC, AB, AD is clearly visible. That is, you can see, when you see from the top, this is the AB, clearly visible. BC, clearly visible. AD is clearly visible. That's what we made it here. Okay. Now we've finished the base visible and invisible edges, and when you see from the top, the slant edge AO, BO is clearly visible, DO is clearly visible, and backside to this one CO is also clearly visible to the eye. So now the same I am going to draw. Take the line AO, BO, C, D. All the slant edges are clearly visible to the eye. So there is no chance of invisible lines in the slant edges. Okay. So we finished the visible and invisible edges. The remaining one is the axis, in the top view axis. So you can see that from this point to this point will be the axis. So to represent clearly, I am just taking it here. Take the line from here to here. center line. Now with this we completed perfectly the orthographic projections of a square pyramid, and the final step is give the dimension. This is the height of the square pyramid and the base side 40 mm. Now you can measure this one also. Yes, so with this we completed orthographic projections of a square pyramid when it is resting on one edge axis is inclined to HP.